Has artificial intelligence truly started to think, or is it just acting so convincingly that it makes us believe it does? These days, this question is not only on the minds of tech enthusiasts, but also scientists, philosophers, and ethicists. Because what we're now facing are not just systems that provide information, but ones that analyze questions, reason through problems, and even explain their own solution paths. If an AI gives you the correct answer, is that enough? Or does the real issue lie in asking how it arrived at that answer, whether it truly understood or merely acted based on statistical memorization? This very distinction could redefine the boundary between humans and machines. Before continuing with the video, don't forget to like and subscribe to my channel for more content like this. Artificial intelligence technology has evolved beyond being just a technical innovation into a phenomenon that raises profound questions about humanity's intellectual capacity. We're no longer talking about a tool that can only write text or generate images. Today's AI can write code, solve complex mathematical problems, break down user questions step by step, and often gives the impression of being a thinking entity. But at this point, we must pause and ask, is it really thinking, or are we just being led to feel that way? The importance of this question grows by the day. As AI's role in our lives expands, so does the meaning we assign to it. We've begun asking not just, does it work, but how human-like is it? And more critically, is it actually thinking? Research aimed at shedding light on these questions is yielding fascinating results. Notably, a recent study by Apple has taken these debates even further. Apple researchers designed a testing system that evaluates not just whether large language models provide correct answers, but also the paths they take to reach those answers. Because the issue is no longer just about the correctness of the outcome, it's about how that outcome was achieved, what reasoning steps were followed, whether errors were detected, and how conscious this entire process appears. In this context, the tested models were challenged with classic intelligence games. These included tasks like the Tower of Hanoi, river crossing, block world, and peg solitaire. Problems that require step-by-step logical progression to solve. These aren't just entertaining puzzles. They're ideal tools for measuring a system's capacity for thinking, planning, foresight, and error correction. Apple restructured these tests with varying difficulty levels to assess the model's robustness and uncover their true logical reasoning abilities. The core objective of the research was this: is a model merely regurgitating patterns it has memorized from past examples, or is it initiating a new reasoning process for each unique situation? This distinction is the most critical factor in determining whether artificial intelligence is truly intelligent. During testing, not only were the model's answers observed, but also how they thought. For instance, when a model responded immediately, it might have relied on pre-existing knowledge. But if, before answering, it engaged in an internal monologue, like, first I need to take this step because the next one won't make sense otherwise, this could be interpreted as a form of reasoning. Apple designed specific scenarios to measure whether models were responding by thinking or without thinking. The initial observations were fascinating. In simple tasks, models performed better without engaging in internal logical explanations, because overthinking only slowed them down and increased errors. However, as difficulty increased, this trend reversed. When faced with more complex problems, models that activated a reasoning process began producing more accurate solutions. In other words, up to a certain point, thinking was a burden, but beyond that threshold, it became a necessity. Yet the story didn't end there. When problems grew even more complex, for example, increasing the Tower of Hanoi disks to 10, all models showed a dramatic drop in performance. Even the most advanced language models failed to solve these long, patience-demanding, systematic thinking challenges. Worse, some models began shortcutting or even skipping reasoning steps entirely, essentially giving up on thinking. This reinforced the view that they're merely systems pretending to think. Another striking detail: models often failed even when given the solution steps outright. In tasks requiring only execution, not reasoning, they struggled to follow sequential instructions reliably. This suggests AI's implementation skills, not just reasoning, are far more limited than we assume. These findings highlight how far AI remains from true thought. Today's large language models can generate plausible answers to complex questions, mimic human behavior, and even impress us at times. But these are largely the results of linguistic mimicry and vast pattern memorization. There's no genuine consciousness, original reasoning, learning from mistakes, or strategic goal-oriented planning. In conclusion, today's artificial intelligence systems may appear to be thinking, but this is merely a well-crafted illusion. Genuine thinking requires intention, awareness, insight, contradiction, resolution, and creative problem solving, none of which have truly entered the domain of artificial intelligence yet. The experiments included advanced large language models, LLMs, like Claude and DeepSeek. These models were tested both in their standard response mode and with an activated thinking process. By thinking process, we mean the models producing lengthy explanations before answering, making step-by-step inferences internally. So what were the results? The first notable observation was that models solving simple-level problems without thinking performed better. For such tasks, extensive thinking unnecessarily consumed tokens and could even mislead the model. However, when the difficulty level increased to medium, models attempting to produce solutions through step-by-step thinking gained an advantage. Thinking became beneficial at these levels. Yet, when faced with truly challenging tasks, all models showed a dramatic decline in performance. In scenarios like the 10-disk Tower of Hanoi problem, where the number of steps exceeds thousands, none of the models could sustain the solution path. Even more interesting was that as difficulty increased, the model's thinking actions began to decrease. In a sense, the system seemed to sense impending failure and stopped thinking, behavior that further strengthens the question of whether AI is truly thinking. Another striking part of the research involved directly providing solution algorithms to the AI. In these tests, the models didn't need to be creative to solve problems. They only had to follow given steps sequentially. Yet even here, the results were surprising. The models failed at implementing ready-made algorithms too. This shows that AIs are extremely limited, not just in thinking capacity, but also in their ability to follow sequences of operations and maintain logical strings. All these findings reveal a clearer truth. Large language models are not thinking in the way we understand. They attempt to generate answers by recalling similar examples from the massive data sets they were trained on and proceeding through probabilities. If the problem they encounter is one frequently seen in training data, they perform quite well. But when faced with novel, never-before-seen situations requiring complex logical sequences, they easily falter. For example, these models can solve Hanoi Tower problems with a few disks because they may have encountered such examples during training. But as the number of disks increases and the solution path lengthens, stepping outside the training data causes the models to struggle. The same is observed in tasks like river crossing puzzles. With few characters, everything works fine. But when complexity increases slightly, models either take wrong steps or abandon the entire process. All this very clearly outlines the boundaries of where AI stands today. AI is an excellent imitator. It can analyze examples it has seen and produce similar ones very well. But when faced with truly new situations requiring creative, systematic, rigorous reasoning, it still falls short. It appears that the AIs we use today are not mathematical engines, but rather language-based prediction machines. They recognize certain patterns, prefer statistical proximity over randomness. But in this process, there is no real thought. There's only a structure that behaves as if it's thinking. Apple's study brings a new perspective to AI. Now we need to focus not just on the answer, but also on the process behind it. Because intelligence lies not just in the outcome, but in the process itself. Thinking, building a sequential structure, analyzing mistakes, and backtracking, trying again. These are things AI still cannot do, at least not in its current form. If more powerful structures are to be built in the coming period, training these systems solely on big data won't be enough. New architectures will be needed to teach them logical thinking, careful tracking, and learning. Perhaps these will be evolved versions of today's models, or perhaps they'll emerge as completely different paradigms. But one thing is certain. Current AIs may appear intelligent, but they cannot truly think yet. The question of whether artificial intelligence truly thinks or merely pretends to do so has become one of the most complex and perplexing issues of our time. The models we have today produce impressive answers, generate lengthy solutions, and even appear to reason step by step. But when we look behind the curtain, it remains a profound mystery how much of this process stems from genuine understanding versus mere statistical pattern matching. Perhaps, despite all these advancements, what's truly fascinating isn't AI's capacity for thought, but its ability to imitate humans so convincingly. In the coming years, the answer to this question won't just shape technology, it will define humanity's future. So what do you think? In your view, is AI truly thinking, or is it just pretending? Don't forget to share your thoughts in the comments. And if you enjoy this kind of content, make sure to like this video and subscribe to my channel for more.